Hello everyone, welcome back to my YouTube channel Pawan's Learn Tech Hub. My name is Pawan Kumariam. Presently I am pursuing as a computer science and engineering graduate in Sri Venkateshwara College of Engineering, Bangalore. So today we're gonna discuss on the topic storage management in the operating systems. Introduction. Storage management. It is the crucial aspect of operating systems. It involves the organization, allocation, and management of the storage resources. The goal is to efficiently use storage space and optimize performance. So here is a flowchart where the storage management is divided into its subdivisions like volume migration, compression, storage virtualization, snapshot and mirroring, process automation, disaster and recovery, replication, and auto processing. So next slide goes to file system. What is file system? It is responsible for organizing and managing files on a storage device. They provide a hierarchical structure to store and retrieve data. Common file systems include FAT32, NTFS, and ext4. Contiguous allocation. Contiguous allocation allocates files in contiguous blocks on a storage device. It provides fast access to files and is suitable for sequential access. However, it can lead to fragmentation and inefficient storage utilization. Linked allocation. Linked allocation uses linked list to allocate files on a storage device. Each file block containing a pointer to the next block in the file. It avoids fragmentation but suffers from slower access times due to traversal of the linked list. Index allocation. Index allocation uses an index block to store pointers to file blocks. The index block contains pointers to each block of the file. It provides fast access and efficient storage utilization but requires additional overhead for the index structure. So next slide goes to the file system implementation. What does file system implementation do in operating system? It involves designing and implementing the software responsible for managing files. It includes components such as file control blocks, directory structures, and disk space allocation algorithms. Different operating systems have different file system implementations, each with its own advantage and limitations also. So here is a flowchart where layered file systems are divided into its subdivisions or follows like application programs followed by logical file system followed by file organization module, then basic file systems, then input output control, lastly devices. So next slide goes to disk scheduling algorithms. What is disk scheduling algorithms? It determines the order in which requests are serviced by the disk. Common algorithms include first come first service FCFS, shortest seek time first TF, and scan. The choice of algorithm affects disk performance in terms of throughput and response time. Here is some full forms of the disk scheduling algorithm. They are divided into two types, like selection according to requester and selection according to requested item. Selection according to the requester, there are four main types like RSS, FIFO, priority, and LIFO. RSS means random scheduling for analysis and simulations. FIFO is first in, first out, fairest of all them all. Priority by process, no disk optimization. LIFO is last in, first out, maximum locality and resources. Selection according to requested items like SSTF, shortest service time first. It is having a high utilization and small queues. Scan is a back and forth over disk. Better service distribution. C-scan, one way with fast return. It is lower service variability. N-step scan of N records at a time. Service guarantees. F-scan is NSSW bar N equal to Q at beginning of a scan cycle. Load sensitivity. Disk catching. Disk catching involves storing frequently accessed data in a cache to improve performance. It reduces disk access time by serving requests from the cache instead of the disk. Caching algorithms such as least recently used LRU and write through are used to manage cache contents. Disk catching are of two types, smart drive and vcache. Smart drive, a hard drive cache program that comes within 3x or DOS that can be executed as a TSF from the autox.bat file. Vcache is a built-in the Win 9x 32-bit software cache that doesn't take up conventional memory space and upper memory space as smart drives does. Next is RAID, redundant array of independent disks. RAID is a storage technology that combines multiple disks in a single logical unit. It provides improved performance, fault tolerance, and data redundancy. Different RAID levels offers different trade-offs between performance, capacity, and redundancy. Disk partitioning. Disk partitioning divides a physical disk into multiple logical sessions. Each partition can be formatted with a file system and used as a separate storage entity. It allows for better organization of data and enables multi-boot configuration. Logical volume management, LVM, where it is a method of managing logical volumes that span multiple physical disks. It provides flexibility in resizing logical volumes and simplifies disk management. LVM allows for a dynamic allocation of storage space without disrupting existing data. Snapshotting and backup. Snapshotting creates a point-in-time copy of a file system or logical volume. It allows for each recovery in case of a data corruption and accidental deletion. Backup involves creating copies of a data for long-term storage and disaster recovery purposes. Storage virtualization. Storage virtualization abstracts physical storage resources and presents them as a virtual storage devices. It simplifies storage management by providing a unified interface for managing multiple storage devices. Virtualization technologies like storage area network, SAN, and network attached storage NAS are commonly used in the storage virtualization concept. So here is the conclusion of this slide. Storage management plays a critical or crucial role in operating systems. It involves file systems, allocation method, disk scheduling, caching, RAID, and other some techniques. Efficient storage management improves system performance, reliability, and data availability. Contiguous memory allocation. Here is a flowchart where the main memory is partitioned and allocated to resident operating system and user process. Thank you.